Okay, in this video I'm going to attempt to give you some background on cylinders. Now these are very difficult to draw on a three-dimensional object on a two-dimensional surface, so you're going to have to use your imagination a bit, but I'll do my best to try to piece together what these things are made of, and more than just using the formulas. And a lot of people can use the formulas, but it's very difficult to remember them unless you know where they come from and why they look the way they do. If you know the why, it's very easy to remember them, or basically derive them yourself if you forget. So let's start with the easy one. The easy one would be considered volume. Okay? And let me put in a couple of measurements. There's really only two things you need to know about the volume formula. Two measurements you need to find, and this is a fairly easy calculation. Okay? I need the radius, which would be from the middle anywhere to the outside edge of that circle. And I need the height, which would just be that distance right there. Okay? Now, if I have that, what I'm really finding here, and this is the why behind it. It's kind of tough to put into words, so I'll see what I can do. When I'm doing this formula, what I'm really doing is I'm finding this area right here. I find the area of that circle. Okay? That's what this is. And then I'm sort of basically saying how many of these flat circles, like the one I just colored in orange, would I have to stack on top of each other to work my way down and to make this entire cylinder. And that should give me the overall three-dimensional space that this solid takes up. And so all I really do is take the radius squared times the height, and I'm done. So if I were to say, for example, let's just put some numbers in there and say, what if my radius was 5 units, whatever that might be, and my height was 10. Okay. Well, to do that calculation, I'm going to say the volume is pi times the radius squared, which would be 5 squared. Now be careful right here. The squared only applies to the 5. It does not apply to the pi. Times a height of 10. Now, all I have to do is kind of simplify that. Let's say we had 5 squared is 25, so this is pi times 25 times 10. Well, a lot of times, I know pi is one of those numbers, it's 3.14, and it's a decimal that keeps on going forever. So instead of rounding it off and having to type it into a calculator, all we really need to do is just take these numbers and multiply them and leave the pi there. So I'm going to call this 250 pi units cubed. Okay? And that's basically all there is to finding volume. Now, surface area is a little tougher. So what I have down here in red is the surface area formula. Okay? And that's the surface area for a cylinder. Now, I'm going to try to attempt to show you what that means. Let's assume that this was like a can that had a top and a bottom on it. And the can was empty in the middle. But how much material would it take to make that outside of that can? How much material covers the outside? Now, let's look to see what it's made up of. Okay, first, I've got a top of the can, which is blue, bottom of the can, which is blue. Those are both circles, so it's basically the same thing I just did right up here. It's pi r squared, and I multiply it by 2 because there's 2 of them. So that's that part of the formula. Now, the other part's a little tougher for me to show, especially on a two-dimensional surface. But if I were to take this rectangle and fold it around and make this end touch this end so that it wraps around that circle, that's where this part of the cylinder, the edge that goes all the way around, that's where it comes from. It's basically a rectangle wrapped around into a tube. Okay? And if you take a piece of paper and just touch one end all the way to the other end and make a tube to look through, okay, like you're making a little kid's telescope, that's basically what you're doing to make a cylinder. Now, this part of the formula, 2 pi r, that represents the distance all the way around a circle. That's the circumference. So this distance right here is 2 pi r, from here to here. When I wrap that around, that's the distance around the circle. That's essentially the length of that rectangle. And here's the height. That's why height is in the formula. So what I've really done is I've added up basically 2 circles, the area of 2 circles, plus the area of one rectangle. And when I add all those together, I get the overall surface area of the cylinder. I'm not talking about the space on the inside. I'm talking basically if I were to make like a Pringles can, how much material would it take to make the outside of the can and the top and the bottom all put together?